Assalamualaikum warahmatullahi wabarakatuh. My name is AHMAD and AZYZEE, and together with my lab partner, Irham and ROSMAN, are going to present about our lab file that is RC and RL, high pass filter. So, for last week, we have done lab 4 that is low pass filter circuit for RL and RC. So, for this week, we are doing high pass filter. Okay, so for the first part is RC high pass filter. For RC high pass filter, this is the part the preset. So I have to find the TF for RC high pass filter. So using this formula, I got 1 plus J omega over 6.447 kilo. And then I have to find the cut-off frequency. So by using this formula up here, that is FC equals to omega C over 2 pi, and omega C is equal to 1 over tau or 1 over RC. I got the omega C equals to 6.447 kilo and FC equals to 1.026 kilohertz. Okay. So for the circuit construction, this is how I construct my circuit. Okay, and then this is to find the cut-off frequency to check whether the theory is valid. So to find the cut-off frequency, so I try to put the input of 1.02 kilohertz, and then since the V out is equals to since the V out is for channel B, so I have to then I go for Y max, and the Y max I got the throughput is 1.413 volt. So in theory, I have to get the V out equals to 0.07707 V out max, and V out max is 2. Meaning that I have to get to manipulate the frequency until I got 0.707 times 2 or 1.414 volt, and this is the closest I get, that is 1.413 volts. Then this is the result from so this is the result from finding the V out for 100 Hz to 10 kHz. Okay, and this is the plot that I get from this data here. So to find the V out, firstly, so for example, if I set to 1 kHz, okay, and then the first one, I go for Y max for the channel A, and then I go the V out is from channel B, so I have to select channel B and change it to channel B, and then I go to find Y max. So this is the since this is V2 and it's the V out, so the V out is here from channel B. It is 1.394 volt. Okay. Or the proof, then get all of it. Okay. And that's it. I'm going to pass the part 2, that is RL circuit, to my lab partner Irham.
Assalamualaikum. My name is Irham Mukhlis bin ROSMAN and will represent the part 2 of RL high pass filter in lab 5. So first, for the transfer function, this is what we get using the formula that are given. So we get Tf equal to 1 plus kW over 25k. And for the cutoff frequency in figure 3, we use the formula that are given. So for the frequency is 25k rad over second, and for the which cutoff frequency from the formula that are given also, we get cutoff frequency equal to 3.979 kilohertz. And then next for the circuit construction, and so for cutoff frequency that we determine from the V out equal to 0.707 V out max, which is V out max equal to 2. So we got about 1.414 volt. So in the TCM, we find that in the frequency of 3.7 kilohertz from RL circuit, we get near to 1.414 volt. So we conclude that we are using 3.7 kilohertz as a cutoff frequency. And for the result, from the result, we use RL, which we have done earlier. This is how we get the cutoff frequency. And then for the V out in 100, we use this is the figure from the RL circuit. So using multisim, we just adjust this and then run it. So this is the what we get. How we get it is by using the cursor. We adjust it to the max on the channel A. Channel A is the V in that apply the volt supply that apply to the circuit. It's about 2 volt, and then we adjust this to channel B. So we refer to cursor to channel B. Channel B is for 15.730 megawatt. So we put it in the table. Then this V out over V in is by using this V out over with the V in that apply is 2 volt. So we get 0.025. And AV in dV, we using this formula, and then this is what we get. And the rest is same with the others. For example, we adjust it to 200 Hz. Okay, this is what we get. So as we have done before, let's adjust this to the highest amplitude of channel A and the highest amplitude for channel B to cursor number 2, 100.405 millivolt, and apply it to the to the table. So this is what we get from the table. It's same. And then this is we have plot the data. This is the data that have been plotted using the table. And this is cache table of approximate straight line approximation of frequency response. The yellow line. And then this is the proof that we have in multisim in the using the different frequency. And for the discussion, the difference between low pass and high pass filter is low pass filter maximum amplitude occur at lower frequency, while high pass filter maximum amplitude occurs at high frequency. Low pass filter attenuate the high frequency, and high pass filter attenuate the low frequency. High pass filter permits high pass frequency to pass from the input through to the output of the filter, while low pass filter permit low frequency to pass from one stage to another. The example of band pass filter is band pass filter are commonly used in audio amplifier circuit. As example, speaker use it to play only a desired range of frequency and ignore the rest of the frequency. While low pass filter and high pass filter are widely used for image processing. Low pass filter is employed to remove high spatial frequency noise from a digital image or to make a smooth image, while high pass filter is used for sharpening the image. And as for the conclusion from the experiment that we are able to determine the transfer function and cutoff frequency for a high pass filter circuit. We also able to determine the frequency response for high pass filter by using straight line approximation of the Bob plot. We also able to make comparison between the actual frequency response and the approximation of frequency response for a high pass filter circuit. Then we are able to differentiate the difference between high pass and low pass filter circuit and explain them in real life application. The high pass filter circuit attenuate the low frequency while permit the high frequency to pass as an output. That's all from me. Thank you.